My dear students in language school, good evening for everybody. Today we will complete what we have started in numerical calculations. We will study how to subtract numbers by complements. Representation of negative numbers using complements. Do you know what is complement? In math, complement is the smallest number. When added to a given natural number, it produces a carry to the next higher digit. So, when we add this number to a natural number, it produces a carry to the next higher digit. Complements are used for representing negative numbers in computers. Let's see complements in different systems. The tens complement means the complement in decimal system. In decimal, the smallest number, which when added produces a carry to next higher digit, like when we say the complement is the complement of 71. The complement of 71 is 29. 29 will produce 100. 100 means the number will have a carry to next higher digit. Let's see how. Now, 29, 71, when we add them in decimal, 9 plus 1 is equal to 10, 0 and 1. 1 plus 2 is equal to 3, 3 plus 7 is equal to 10. In decimal we put 10, so we take a carry to the third one. We make here a third digit. So here the complement of 71 is 29. Now, moving to 6, 3, 5. Is 365. How? Because 365 when added to 635, let's add 5 plus 5 is equal to 10. Take a carry 1. 1 plus 3 plus 6 is equal to 10. 0. We have a carry to the next digit. 1 plus 6 plus 3 is equal to 10. So the numbers are be added to a next digit. Here the numbers are of 3 digits. The result number is of 4 digits, 1000. So let's say in a simple way, the complement of 6. The complement is 6 is 4. Why? Because when we add 6 to 4, we move to we have a carry. Here to the next digit we have 10. Here 6 and 4 are numbers of 1 digit. Then the resulted number is of 2 digits. This is the idea of complement in decimal system. The second complement means the complement in binary system, in a system of these two. In binary, the smallest number, which when added, produce a carry to next higher digit. How? How to calculate the second complement or the binary complement? For each digit of original binary number, invert zeros to ones. It's very easy. Invert each 0 to 1 and ones to 0. And then when you invert all digits, add 1 to the end to obtain the result. Add 1, yes. Let's see an example. The second complement of 0, 1, 0, 1. The binary number 0, 1, 0, 1. Now, by inverting each digit from 0 to 1 and 1 to 0, can you make it? Yes. This 1 will become 0. This 1 will become 1. This 1 will become 0. This 1 will become 1. Have we finished? No, we need to add 1. Now, when adding 0 plus 1, 1 only? Yes, 1. 0 to 1, it resulted to 1. Then 1 by nothing will be added to nothing, 1 as it is, 0 as it is, 1. Is it added to nothing? No. The representation of the number 1 in binary is 1, 0, 0, 0. So here we add to 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. We are clever now in binary addition. We have studied this lesson in the previous lesson. Now the subtraction. The subtraction. How we can use complements in subtraction. A computer uses subtraction by performing addition with complement. So instead of making a subtraction, you add the number to the complement of the next number. So subtraction process will be as follows. Find the complement of the subtrahend. Use the complement to perform addition, and then ignore the leading digit. This is very important. See? In decimal, how to make it? The complement of the second number, not the first, the complement of the second number. We have discussed it before. The complement of 6 is 4. So 8 minus 6 here equals 8 plus 4. So the result will be 12. Now ignore the leading one. The result will be 2. 2? Yes. Make it in your hands as in primary school. Take 8 and remove 6. The result will be 2. Now the binary subtraction. We have 3 steps. First, we find the complement of the second number, the subtrahend. So we need to have the complement of this number. The complement of this number, how it could be 1, 0, 0, 1. Let's see how. 0, 1, 1, 1. Invert each digit to 0 or 1. 0, 0, 0, 1. Now the second step is to add 1. 1, 0, 0, 1. Correct. The first step is correct. So now we need 2. 1, 0, 0, 0 minus 0, 1, 1, 1 means this number. How we can got this number? Let's see the number we have got as a complement and add to the first number. Now 1, 0, 0, 0, 1, 0, 0, 1. Add 1, 0, 0, and 0 1. It's time to ignore this. The result is correct. Now let us practice together. What is the complement of the following binary number? Now take it 1, 0, 0, 1. Invert 0, 1, 1, 0. Now add 1. So the result will be 1, 1, 1, 0. Let's check. By inverting each digit from 0 to 1 and from 1 to 0, the result is 0, 1, 1, 0. And finally, by adding 1, it will become 0, 1, 1, 1. So our answer is correct. Put your notebook beside, take your pen and calculate with me. What is the complement of the following binary number 0, 1, 1, 0, 1, 0, 0? Take it 0, 1, 0, 0. Okay, let's invert 1, 1, 0, 1. Now add 1. Okay, do you remember adding? 1 plus 1 equal to 0. And we will carry 1 here. 1 plus 1 is equal to 0. And we will carry 1 here. 1 plus 0 is equal to 1. And 1 plus 0 is equal to 1. So the result is 1, 1, 0, 0. Let's check. Now by inverting digits from 0 to 1 and 1 to 0, the number will be 1, 0, 1, 1. Okay, now by adding 1, the result will become 1, 1, 0, 0. Very good. Now use complement to perform the following binary subtraction. The first step is to get the complement of the second number. So, as we did before, 0, we take this number, 0, 1, 1, 1. Let's convert 0, 0, 0, 1. Now add 1. The result will be 1, 0, 0, 1. Now this is the complement. So the first number will be added to the complement. Let's see. 1, 1, 0, 0 will be added to the complement, which is 1, 0, 0, 1. Now add 0 plus 1, 1, 0 plus 0, 0, 1 plus 0, 0, and 1 plus 1 is equal to 0, 1. What will we do next? We will ignore the leading 1 and the result will be 0, 0, 0, 1. Let's check. Yes, we need 1 here. Yes, yes, yes. Okay. What 0 plus 1 equal 1, 0 plus 0 equal 0, 1 plus 1 equal 1, 1 plus 1 equal 10. So 1, 0, 1, 0, 1, this is correct. 1, 0, 1, 0, 1. By removing the leading 1, the result will be 0, 1, 0. Now another example. Use complement to perform the following binary subtraction. The first step is to get the complement of this number. How we make it? 1, 0, 0, 1. Now we invert each 1 to 0 and each 0 to 1. So the number will be 0, 1, 1, 0. Now add 1. The number will be 1, 1, 1, and 0. Now we will add 1, 1, 1, 0, 2, 1, 1, 1, 0. So 0 plus 1 is equal to 1. 1 plus 1 is equal to 0 and carry 1. Now 1 plus 1 plus 1 is equal to 1 and add 1. 1 plus 1 is equal to 0, 1. So ignore the leading 1. The result will be 0, 1, 0, 1. Correct? 1, 1, 1, 0 minus 1, 0, 0, 1 is equal to 1, 1, 1, 1 plus 0, 1, 1, 1. The complement we have calculated here. When we add them together, it will result to 1, 0, 1, 0, 1. And by ignoring this one, the result will be correct as we did. Now another example. What is the complement of the following binary number? 0, 1, 0, 1. Okay, can you do it? Yes, invert please. Each 0 to 1 and each 1 to 0. 1, 0, 1, 0. Is it enough? No, we need to add 1. 1, 1, 0, 1. So the complement of this number is this number. Yes, our answer is correct. When inverting 0 to 1 and 1 to 0, the result will be 1, 0, 1, 0. And by adding 1, the result will be 1, 0, 1, 1. I think it's very easy now. Let's complete. What is the complement of the following binary number? Yes. Please invert. Invert 1 to 0. 0 to 1. 1 to 0. 1 to 0. Now add 1 here. Let's add 0 to 1 is equal to 1. What completes the number here? 0, 0, 0. So 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. Don't forget the base. Here your answer is complete. I want you to get the highest marks in the class. Check your answer by inverting 0 to 1 and 1 to 0. It becomes 0, 0, 1, 0. Then adding 1, it will become to 0, 0, 1, 1. We have a large binary number. But don't afraid, it's the same way. Try. Now invert each 1 to 0 and each 0 to 1. 0, 1, 1, 1, 0, 0, 1, 0. Is it enough? No, we need to add 1 to this number. Yes, add 1. What are the next? 0, 0, 0, 0, 0, 0, 0. Now, 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. And 0 plus 0 is equal to 1. Here is the complement in a very easy way. And don't forget the base 2. Okay, the same number here. When we invert from 0 to 1 and 1 to 0, it becomes, as we said, and then finally by adding 1, it becomes 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0. What is the complement of the following binary? Now we know the way, so we will answer together. Invert from 0 to 1 and from 1 to 0. Now 1, 1, 0, 0, 1, 1, 0, 1. Is it enough? No, we need to add 1. 1 plus 1 is equal to 0, and we carry 1 here. So let's complete the number. Hey, 1 plus 1 is equal to 0 again, and we add 1. 1 plus 0 is equal to 1. 0, 1, 1, 0, 1. Don't forget base 2. Let's check. Now, by inverting from 0 to 1 and 1 to 0, it becomes, as we said, 1, 1, 0, 0, 1, 1, 0, 1. By adding 1, it will be 0, 0, 1, 0, 1, 1, 0, 1. I think it's clear now. Use complements to perform the following binary subtraction. Now we need to get the complement of this number. Okay, 0, 1, 1, 0. Invert each one to 0 and each 0 to 1. 1, 0, 0, 1. Now add 1. 1 plus 1 is equal to 0. And we carry 1. 1 plus 0 is equal to 1. Now put the 0 and the 1. So this is the complement. Okay, now add the complement to this number. 1, 1, 0, 1, 1, 0, 1, 0. Adding 1 to 0 is 1. 0 to 1 is 1. 1 to 0 is 1. 1 to 1 is 0, and we carry 1 to the next higher digit. So the result here is 1, and we need to ignore this 1. And so the result will be 0, 1, 1, 1. Yes? Now inverting this number, the second number, to 1, 0, 1, 0, as we did, then we adding 1, 1, 0, 1, 1, 0, 1, 1. The result 1, 1, 0, 1 plus 1, 0, 1, 0 is 1, 0, 1, 1, 1. And when removing the leading 1, the number will be correct. Now use the complement to perform the following binary subtraction. Hey, do we remember what we have did? Yes, we invert the second number. I hear you. Very good. Take it. 0, 1, 1, 1. Invert each one to 0 and it's 0 to 1. So the result will be 0, 0, 0, 1. Now, add 1. Don't forget to put the zeros. So 0 plus 1 is equal to 1. 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. 1 plus 1, 1 plus 0 is equal to 1. Okay, so this is the complement. Now add the complement to the first number. So 1, 0, 1, 0 plus 1, 0, 0, 1. Now add 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 0 plus 0 is equal to 0. 1 plus 1 is equal to 0 and 1. So 1, 1, 0, 0, 1. Now remove this. It will be 1, 1, 0, 0. Don't forget the base. Here we invert, then add to the next number, and the result will be as we said. Now use the complement to perform the following binary subtraction. First, give the complementary of this number 1, 0, 1, 0. Give the complementary. Invert zeros to ones and ones to zeros. 0, 1, 0. Now add 1. 1 plus 1 is equal to 0 and take 1 to the next. 1 plus 0 is equal to 1, then 1 and 0. So remove the base. Now we need to add this number to the first number. Take it. 1, 1, 0, 1. And 0, 1, 1, 0. Now add 1 plus 0 is equal to 1. Equal to 1. 0 plus 1 is equal to 1 too. 1 plus 1 is equal to 0 and take 1 here. 1 plus 0 is equal to 0 and take 1 here. 1 plus 0 is equal to 1. Now ignore the leading. So let's see the result. Now by inverting 1, 0, 1, 0 to get x complement, the result will be 0, 1, 1, 0. When adding 0, 1, 1, 0 to 1, 1, 0, 1, the result will be 1, 0, 0, 1, 1. Now by removing the leading number 1, the result will be 0, 0, 1, 1. Thank you very much, my dear students. I think the lesson is clear. We need to practice well and put your notebook beside. Check the answers and make sure that you're performing well. Thank you very much for listening and following. With my greetings from Miss Rania Nakor.